Hi, the section 4K, the continuous varying annuities. So we start with a review of chapter 4D, then gradually we deal with more general case. So case 1. So this is the 4.D. So recall that a continuous cash flow at $1 per annum for n year is worth 1 minus v to the nth power over log of 1 plus I. Okay, so this was also written as the 1 minus v to the power n over delta. So what is the justification behind this? So that is basically the integral calculus, and we use the definition of integral. So we have n years, and we have basically constant payments over n years. So $1 per annum, $1 per year. That means if we think about the year t and year t plus delta t is very small quantity, then rate is $1 per year. So this area is actually the delta t times 1. So this is the area of delta t. So this the shadowed cash flow. So what's the present value of this shadowed cash flow? So we go back t years. So we have to multiply the v to the power t. So v to the power t times the delta t. So that is the basically present value of this shadowed cash flow. So that this shadowed cash flow is worth the v to the power t delta t. So if we want to calculate the present value of the entire cash flow, we have to integrate this from the 0 to n. T is equal to 0 to n. So the present value, PV, is equal to the integral, the 0 to n, v to the power t delta t. So if we go back to the definition of integral, the adding up this, the vt times delta t with small delta t, infinitely small delta t, becomes the integral 0 to n v to the power t dt. So what is this? So this is the exponential function, the v to the power t. So the base is v and the exponent is t. So this becomes v to the power t over log of v. Then we plug in n and 0. And remember that the v is equal to 1 plus I over 1. So 1 over 1 plus I. Okay. So the log of v is equal to negative of log of 1 plus I. So that means this is equal to the v to the power n minus 1 over log of 1 plus I. Maybe I will say that the log of v. So log of v is negative log of 1 plus I. So we can write this as 1 minus vn. This has the same numerator as a right angle n, and over log of 1 plus I. So this was the case in 4.D. Okay, so now the case 2, more general case. So more generally, that we think about the continuous cash flow of the f of t dollar per annum at time t. So this changes over time. And still that we consider the constant interest rate, so I is constant. we generalize it in a later case, but in a later case, the third case. But the okay, so for now, the payment rate changes, but the interest rate is constant. So here is T, and this is the payment rate. F of T, so dollar per year. So now that this changes over time. So like this. So this is Y is equal to F of T. So what is the present value of cash flow between time T and time T plus delta T? Then this area, okay, so this height is F of T. So this area is approximately F of T times delta T. So that means the present value of this shadowed area is equal to the V to the power T times Ft times delta T. So that means the present value, the entire quantity, is equal to the integral of this. Integral 0 to n, the V to the power T times F of T times delta T. So of course, it depends on F of T, how easy to integrate this function. But in general, at least we can have this integral form.